Let's do some application of exponential growth here in this problem. So we've got a graphic of number of new life forms and days since discovery. So we're going to use this graphic to answer a few questions. Now, letter A. How are the number of life forms changing from day to day? Well, I'm just going to use these last two. This one's new and this one's old. So I can find a growth factor. Growth factor describes how they're changing by taking new divided by old. So 640 divided by 320 is 2. That means they are doubling. And you might have just seen that by looking, but now if I'm using a problem, my growth factor is 2. Okay, well, what's the initial value? Well, at 0, the initial value is 40. Unit of measure for time? Well, look at the axis. The axis says days since discovery, so the unit of measure for time is days. Construct a model which represents the number of life forms given the number of days. Well, y equals, my initial value we said was 40. We found our growth factor to be 2. And then x represents the number of days. And this would be my model. Okay, so we can use guess and check to figure out when we're going to reach 2,000. So I have this model. And first you might say, well, let's start with 5. So if I say x is 5, then I would plug it in. Y equals 40 times 2 to the 5th, and you can try whatever you want. And that's going to give me an answer of 1280. Well, that's not big enough. I need 2,000. But I know it doubles. Let's try 6. So y equals 40 times 2 to the 6th power, and that gives me 2560. Ta-da! So when will the number of life forms reach 2,000? Well, between 5 and 6 years. Because at 5 years it's too low, but at 6 years it's above, so sometimes between 5 and 6. If they just want 1 year, you would say 6 years. Because at 5 years you're too low. So if they just want a single year answer, the answer is 6. All right, let's go to the next problem. Students in a microbiology class were conducting an experiment to see how certain bacteria spread in an agar plate. An agar plate is like a petri dish. If you ever took a biology or a science class in high school, you probably had those. They had like nasty gel stuff that looked really, really gross on it. But you put stuff on it, right, and then the bacteria grew. Okay, so they found that one particular bacteria could be modeled using the equation B equals, let me write, what is happening? My iPad is being dumb. B equals 10 times 4 raised to the D power, where B is the area of the bacteria on the agar plate expressed in square millimeters, and D represents the days of incubation. So what is the area of bacteria at the start? Well, at the start, we haven't done anything. There's been no days. So B equals 10 times 4 raised to the 0. Hopefully you remember that anything to the 0 power is 1. So therefore, the area of the bacteria is 10 square millimeters to start. Okay, now, darn it, what is the area of the bacteria after 2 days? Well, 10 times 4 to the 2 days. We do the exponent first, then multiply by 10, and we get 160 square millimeters. And after 4 days, well, we plug in 4 for x. Again, exponent first, then multiply by 10, and we get 2,560 square millimeters. Which day will the bacteria basically take over the petri dish if the approximate area is 10,000 square millimeters? Well, we just found that when x is 4, the bacteria was 2,560 square millimeters. If you're paying attention, the growth factor is 4, meaning you're multiplying everything by 4. So if I plug in x equals 5, oops, I'm not using b. B equals 10 times 4 to the 5th, exponent first, then multiply by 10, I get 10,240 square millimeters. So approximately 5 days, and that bacteria will take over the petri dish. And then you say, ooh, gross, because bacteria is gross. And that's the end of that application video.